Welcome. Today, we're tackling a mystery that absolutely shook the astronomical community to its core. We're going to treat astrophysics like a high-stakes detective case. Throughout this explainer, we'll dissect the arrival of a true cosmic intruder. This object is known as Oumuamua. Now, that's a name that roughly translates in Hawaiian to messenger from afar. And the message it brought us? Well, that's exactly what we're here to investigate.
Okay, let's dive into this. Astrophysicist Patrick Michel actually states it perfectly. He says, scientific research is actually an extremely difficult police investigation. And man, back in October 2017, the discovery of Oumuamua literally turned astronomers worldwide into cosmic detectives. Overnight, they were faced with a totally unknown suspect, a huge number of weird parameters, and only a very, very brief window of time to gather evidence before the suspect essentially fled the scene.
So think about it. What do you do when a mystery object from another star speeds through our solar system and seemingly breaks the laws of physics? The whole investigation kicked off at the Pan-STARRS Observatory in Hawaii, which, is optimized to scan the sky for near-Earth objects. Astronomer Robert Warwick noticed this weird anomaly in the data. It was this ball of light rocketing past the sun, but it wasn't exactly where it was supposed to be. It was moving way too fast, nearly 100,000 kilometers per hour. And its trajectory? That proved it wasn't gravitationally bound to our sun at all. It came from outside our solar system. Literally, the first interstellar object ever observed. But as it zoomed away, it suddenly changed direction in a way that just completely defied standard physics.
Section 1. Gathering the Cosmic Clues.
So, how exactly do you solve a mystery when your main suspect is hurtling away into deep space? You build an evidence board. Telescopes all over the world focused on Oumuamua for an intense 11-week period. The Spitzer Space Telescope helped pin down its size. It was around 100 meters long. But the shape, that is where things get super weird. By measuring its brightness as it tumbled through space every 7 to 8 hours, researchers saw a massive 10 times variation in luminosity. Now, a spherical object's brightness stays pretty flat. A 10-to-1 variation means Oumuamua was extremely elongated. We're talking shaped like a long cigar or maybe a flat pancake. Then there's the speed, proving its interstellar origin. And finally, the most crucial anomaly of them all, non-gravitational acceleration.
Let's compare this bizarre behavior to standard space rocks. We all know comets are famous for having a tail, right? As they get close to the sun, their frozen water and gases sublimate into vapor. This outgassing basically acts like a tiny rocket engine, pushing the comet and giving it that non-gravitational acceleration. Asteroids, on the other hand, are just dry rocks. No gas, no tail, and their paths are entirely dictated by gravity. The core mystery of Oumuamua is that it looked exactly like an asteroid. There was absolutely zero dust or gas detected. Yet, it unexpectedly accelerated and changed trajectory just like a comet. It was behaving like a completely new class of object.
Section 2. Suspect 1. Artificial alien technology.
An object with no tail, accelerating like a rocket engine? This missing piece of the puzzle led to some, explosive hypotheses, bringing us to Harvard astronomer Avi Loeb. He argued that given its extreme shape, its unprecedented acceleration without a cometary tail, and just its sheer unusualness, we have to put the possibility on the table that Oumuamua was manufactured by an alien civilization. Now, in a thorough scientific investigation, we have to remember that even the most extraordinary theories must be examined impartially based solely on the physical data.
And this brilliantly illustrates the concept of a solar sail. See, light unleashes energy in the form of photons. And even without mass, those photons carry energy and can actually put physical pressure on objects. Loeb proposed that if Oumuamua was roughly 100 meters long but less than a millimeter thick, the sheer radiation pressure of sunlight could act as a sail. This would provide that mysterious extra push away from the sun without needing any exhaust or comet tail at all. And it's not just sci-fi, it's a technology we are actually developing right here on Earth.
But a good detective always follows up on leads, right? The SETI Institute swung 42 satellite dishes at the Allen Telescope Array to listen in on Oumuamua. They rigorously scanned for technological signatures and radio signals. The result? Total silence. 0 technological signatures were detected. Now, while the vast majority of the scientific community rejects the alien hypothesis, Loeb maintains that even without a radio signal, Oumuamua could still be inert. It could be wrecked extraterrestrial debris just drifting through space, kind of like a ghost ship.
Section 3. Suspect 2. The Dark Comet. Of course, science requires us to test natural explanations first.
Astrophysicist Darrell Seligman and chemist Jennifer Bergner looked at other near-Earth objects that accelerate without visible comet tails. They theorized Oumuamua could simply be a natural interstellar variant. The idea is that over millions of years in the immense, freezing cold of deep space, cosmic radiation would bombard the object, breaking down water molecules into hydrogen. Because of the extreme cold, this hydrogen gets trapped in porous powder-like ice. Then, when Oumuamua passed by our sun, the heat altered the ice structure, releasing all that trapped hydrogen. Since hydrogen gas is completely invisible to our telescopes, it would provide that hidden rocket thruster effect without producing a visible comet tail.
Honestly, it's a very elegant, natural solution, but it's not a closed case. Cambridge astrophysicist Roman Rafikov points out a pretty major physical flaw in this outgassing theory. Because Oumuamua's shape is so irregular, remember that extreme cigar or pancake shape, any outgassing pushing it forward would also act as an immense torque. It would spin the object up violently. According to Rafikov, these forces would have spun Oumuamua so incredibly fast it would have shattered into pieces in a matter of days. Yet our observations showed it survived its journey and its rotation remained reasonably stable. So the anomaly remains a mystery.
Section 4. The threat of cosmic collision. Now, what's really interesting about this slide is why it actually matters exactly what Oumuamua is. It matters because interstellar objects pose an incredibly unique threat to Earth. Let's just look at the math of an impact. If a normal, local asteroid the exact same size and mass as Oumuamua were to hit Earth at a typical speed, say 15 to 17 kilometers per second, it would unleash about 24 megatons of energy. To put that into perspective, that is the equivalent of 1,700 Hiroshima bombs. Devastating, certainly.
But interstellar objects, they do not play by local rules. Because they are falling into our solar system from the depths of deep space, they travel at absolutely terrifying velocities. Oumuamua reached a blistering 87 kilometers per second. And because impact energy increases by the square of the speed, that exact same 100-meter object hitting us at interstellar speeds would unleash 6,700 megatons of energy. That is 45,000 Hiroshimas. An impact of that magnitude would literally wipe a massive landmass entirely off the map.
Which brings us to where we stand with planetary defense. We know the stakes. 66 million years ago, a massive impact shrouded the Earth in toxic darkness. But today, we're fighting back. In September 2022, NASA's DART mission successfully slammed a probe right into the asteroid Dimorphos, proving we can actually alter an asteroid's trajectory. But here is the terrifying catch. DART only works if we have years of advance notice to intercept a slow, predictable object. If an ultra-fast, stealthy interstellar object like Oumuamua were on a collision course, our warning time would be essentially zero. It's a massive, unmitigated threat.
Section 5. Catching the next visitor.
So the crucial point is that Oumuamua was a wake-up call. It highlighted a massive blind spot in our planetary defense. How do we solve the mystery and protect ourselves? By catching the next one. We need a major upgrade in early detection. The deployment of the Vera Rubin telescope is going to allow us to spot these ultra-fast objects much earlier and with vastly improved quality. And the best part? We won't just watch them fly by anymore. The European Space Agency is launching a Comet Interceptor mission in 2029. It will travel 1.5 million kilometers away and literally wait in a standby orbit. When Vera Rubin spots a suitable interstellar target, that interceptor will chase it down to capture a highly detailed 3D portrait.
But what if we want to solve the original mystery? What if we want to catch Oumuamua itself? This is incredibly exciting. Project Lyra is a bold plan utilizing tech currently in development for a launch between 2035 and 2040. To catch an object moving this insanely fast, they plan to use Avi Loeb's solar sail concept, but engineer it ourselves. Step 1. Fire a high-powered Earth-based laser at a probe equipped with a solar sail. Step 2. That immense light pressure propels the probe to an unbelievable 300 kilometers per second. That's 10 times Oumuamua's speed. Step 3. It intercepts Oumuamua in just 440 days. We could literally chase it down deep into space to find out once and for all if it's a dark comet, planetary debris, or a piece of alien tech.
This investigation is far from over. Oumuamua proved that our solar system is not an isolated island. We're constantly being visited by material from the broader Milky Way. And some scientists point out that the red coloring of Oumuamua indicates a composition potentially rich in organic ingredients. It really leaves us with a profound question. If the next interstellar visitor carries the very building blocks of life, will humanity's cosmic detectives be ready to intercept it and read its message? Thanks for joining me on this explainer. Keep your eyes on the stars and stay curious.